Welcome to this video, where we're going to explore one of the most important concepts in PyTorch, distributed and multiprocessing. If you've been working on large-scale machine learning projects, you know how crucial it is to utilize multiple GPUs or even multiple machines to speed up your training process. However, if you're new to PyTorch or parallel processing, this concept can seem daunting at first. In this video, we'll break down the concept of PyTorch distributed and multiprocessing in a way that's easy to understand, even for those without prior experience. We'll cover how processes execute in PyTorch, what happens when you create multiple processes, and most importantly, why they execute from the start of the whole script, not just the place where they're created. So, let's dive into the main topic. When working with PyTorch, distributed and multiprocessing, it's essential to understand how processes work. A process is an independent entity that runs in parallel with other processes. In PyTorch, when you create multiple processes, each process has its own memory space and can run concurrently. Now, here's where things get interesting. When you create a new process in PyTorch, it doesn't just start executing from the line of code where it was created. Instead, the entire script is executed again from the very beginning for each process. This means that if you have some initialization code at the top of your script, every process will execute that code. To illustrate this concept, imagine you're writing a script that loads a large dataset and then creates multiple processes to train different models in parallel. If your dataset loading code is at the top of the script, each process will load the entire dataset again, even though it's already been loaded by the main process. This can lead to wasted resources and slow down your training process. But why does PyTorch behave this way? The reason lies in how processes are created. When you create a new process, PyTorch forks the current process, which means it creates a copy of the current memory space. However, this copying process doesn't just copy the current state. It also copies the entire execution history. This means that every process has its own copy of the entire script and executes it from the beginning. So what are the from this discussion first? Remember that in PyTorch distributed and multiprocessing, processes execute from the start of the whole script, not just the place where they're created. This means you need to be mindful of how your code is structured, especially when it comes to initialization and loading data. Second, keep in mind that every process has its own memory space and can run concurrently with other processes. However, this also means that resources like datasets and models are duplicated across processes unless you take explicit steps to share them. Finally, remember that PyTorch's behavior is not unique. Many parallel processing frameworks behave similarly. Understanding how processes work in PyTorch will help you write more efficient and scalable code. In PyTorch, distributed and multiprocessing can seem complex at first, but by understanding how processes execute from the start of the whole script, you can unlock the full potential of parallel processing in PyTorch. If you have any questions or need further clarification on this topic, please leave a comment below. Don't forget to like this video. If it helped you understand PyTorch distributed and multiprocessing better, and if you are new here, consider subscribing for more tutorials and explanations on machine learning and PyTorch. Thanks for watching, and we'll see you in the next video.